This is a lecture on pH calculations for Chapter 4, Math 107. This diagram of a water molecule can give you a little background as to what pH is actually measuring. As you can see here, water is a polar molecule. That means part of it has a little bit more of a negative charge, and another area of it here by the hydrogens has a little more positive charge. Of course, there's attraction between the positive and negative charges, and that puts a little bit of a force on this hydrogen ion, and it can dissociate from the water. It can break off by itself, and this leaves, of course, the hydroxyl ion. Only a very few molecules in water dissociate like that, but it's important to measure the concentration of the hydrogen ion. We're going to use here the chemistry notation that the square brackets means concentration. Okay, it's molar concentration, but you don't have to worry about that here. It will only be a number. Now, the concentration of hydrogen ions increases if there is another acid present and decreases in the presence of a base. So when other things are dissolved in the water, then there's a change in the concentration of the hydrogen ion, and that's what the pH is measuring. And here's a statement of that dissociation. Of course, this arrow does go both ways because the hydrogen and the hydroxyl can reassemble into the water. This is sort of a dynamic process in the water. Here are some typical values for the hydrogen ion concentration for pure, or rather should have said neutral water here. I guess might be a better term. Chemists would probably have their own term here. But the hydrogen ion concentration is 10 to the minus 7. Lemon juice is very acidic. Of course, it's dissolved in water, of course. 10 to the minus 3. And bleach is very basic or alkaline, 10 to the minus 7, or 10 to the minus 11. Note that although the 11 is a big number, 10 to the minus 11 is a very small number. Also here you have 10 to the minus 3. 3 is a smaller number. This is actually, this is a bigger concentration, even though the 3 is smaller because of the presence of that negative sign. What the pH does is simplify the way to write these values for the hydrogen ion concentration. You might think of how this could be handy. In the olden days, we typed on mechanical typewriters. And if you wanted to put a superscript on something, you had to take off this brake on the roller. Then you had to carefully move the paper, sometimes with numerous carbon copies underneath it, but you had to kind of roll that paper down, type in your value, the minus 7, then you had to return it, hopefully, to the same place, and then put that brake back on the roller, and then go on typing. Aligning this was a real art and required great skill. So it would be nice to dispense with it. If all of these are 10 to the something, then all we really care about is the something, and that's what pH does for you. So here's how you take pH. pH is the negative, remember there's a negative here, of the log of the hydrogen ion concentration. So for water, we had 10 to the minus 7. We put the 10 to the minus 7 here. You have to be a little careful with signs. What happens when you take the log of something with an exponent? Well, the exponent comes out in front, and that's what we see the minus 7 here. The log to the base 10 of 10 is 1, so this is just minus a negative 7, and that's why that's 7. In effect, what the pH did was grab this 7. Look at it for lemon juice. Here we have minus the log of 10 to the minus 3. Same process happens. The minus 3 comes out in front. And of course, log to the base 10 of 10 is 1, so the answer is 3. Again, all the pH did was grab this little minus 3. And for bleach, of course, the pH is 11. Note here, you have to be careful. This is for your neutral water here, but this is a smaller number, is actually a larger concentration. And this bigger number of 11 is actually a smaller concentration because it's really, the real concentration is 10 to the minus 11, not 11. So here's a typical pH scale. Battery acid is very acidic. Notice that screen, notice that -1 is listed. It is possible that the pH is negative. That would be the case in which you have a very high hydrogen ion concentration, in which a concentration of hydrogen ions is greater than, well, it's greater than 10 to the -1. Okay? Let me just show you how that would be. Okay, if I'm taking the pH, it's minus the log, and let's say this is a big number. All right? Then what happens in this calculation? The 2 comes out in front. Log to the base 10 is 1. So the answer is -2. That was an exaggeration, but now you see how you could have a negative pH. If this exponent on the 10 is not negative, then this negative sign will remain at the end of the calculation and you'll have a negative value. This is not common, but there it is. Okay. Now you see others listed. Here's gastric fluid, vinegar, lemon juice, and now here we have freshly distilled water at 7. In blood, the pH in blood, when people measure this in the lab, is about 7.45. There's some plus or minus there, depending on whether you're a little acidic or a little alkaline. Look at seawater compared to distilled water. So the hydrogen ion concentration of seawater would be something like 10 to the -8. And now we're getting, these are more and more acidic, or more and more alkaline, to where you've got bleach here. Oh, they're listing bleach here at less than what I did. I put bleach at 11. Okay, so I had weak bleach. And here's lye. Make soap out of lye. Very alkaline. And again, as the numbers get smaller, you have more of the hydrogen ions concentration, greater hydrogen ion concentration. And as the numbers get bigger, going down in this direction, you have a smaller. Less is probably the wrong word to use in that case, English, but you have the hydrogen ion concentration is less. So when you're required to take the hydrogen ion, or find the pH, you need first this concentration of hydrogen ions. And if it's a simple case, for example, let's say the pH is, the hydrogen ion concentration is 10 to the minus something, let's say 9, then that's easy. Minus the log of 10 to the -9. The -9 comes out in front. Remember, you've still got a negative sign there. Times the log to the base 10. Log to the base 10 is 1. So this gives you minus a -9, which is 9. You can even do it by inspection. If the hydrogen ion concentration is 10 to the -9, the pH, whoops, it won't be -9, the pH will be 9. I see, I wrote sideways and the pen only wants to go like that. There, you just grab that for the hydrogen ion concentration. What happens if you have a case like this, 4 times 10 to the -7? Now you have to do a little bit more work with your logarithms. So I'm taking minus a log of 4 times 10 to the -7. Remember the rule? Let me erase everything on this board. Okay. Here's the rule for logarithms. If I have 2, I'll call them a and b multiplied together. That can be broken out as the log of a plus the log of b. So when we have the log of 4 times 10 to the -7, we can break that out as the log of 4 plus the log of 10 to the -7. Do that step first. But remember, you've got to pay attention to PEMDAS, and you have to use parentheses. Remember, this negative sign that's out in front here is negative of the entire log. So when you break this into 2 pieces, let me do that down here. If this was negative, then it would have to be negative of both of these. That's why I put the parentheses in here and here. Okay, now you can work inside the parentheses. And a log of 4 is 0.6020. And the log of 10 to the -7, as done before, is -7. Then you subtract, and here's your answer. Okay, So I just want to point that out. When you have something like 4 times 10 to the minus 7, remember the negative sign multiplies the entire log. So you use parentheses and break the log into two pieces. The constant here, you just take this pen I've got here. This number can be done on a computer. The second term, log of 10 to the minus 7, is done by inspection. Remember, the minus 7 would come out in front, and log to the base 10 is 1. So there you have your answer. And be sure you subtract within the parentheses before or distribute the negative sign through. If you get a very big negative number, you might have done something wrong. Okay, now let's go the other way. Say you're given pH and you want to find the concentration. Well, what you use is exponentiation. Recall that if I have, I'll just use x, the log of x, and if that is raised to 10, because this is base 10, remember, so if I go 10 log, I'm going to put the 10 in there for reference, the answer is x. This is very, very awkward notation in math, very awkward. What you're really doing is composing the two, and it's very awkward. You're used to doing it the other way. If I have 10 to the x and I take the log, then that procedure seems more straightforward. We say the x comes out front, log to the base 10 of 10 is 1, and the answer is x. Log and exponentiation to the same base are inverses. It's easy to see here, it's harder to see here, but it works both ways. Okay, so let's go and look at the pH now. pH is minus a log of the hydrogen ion concentration. First thing to do is multiply by minus 1, so the negative sign's multiplying the pH. Now raise everything to the 10th, as an exponent of 10. So exponentiate everything using 10 as a base. So this side is 10, and the minus pH goes up on top here, becomes the exponent. Over here, same thing happens. But just like this example, the log and the exponentiation to base 10 are inverses. So the whole answer on this side is just the hydrogen ion concentration, and over here you have 10 to the minus pH. Right. So say you're given pH equals 6. Well, 10 to the minus 6 would be here on the left-hand side, and this is the hydrogen ion concentration, and that's the answer. If it's more complicated than that, well, sometimes people are very clever and can figure out how to do things, but for this class, that's fine. Basically, you would go to your calculator and work it out, so it's okay to have a number up there. Let me show you what I mean. What if the pH is 6.8? All right, then 10 to the minus 6.8 is the hydrogen ion concentration. And you can go to your calculator, and the calculator can handle a number like that fine.